Hello everyone, my name is Ashley Russell and my partner for this project is Danica Dvorchak, and this is part one of our data mining project. So first I'm going to start off by defining what data mining is and why it's important. Data mining is finding practical and usable information from large sets of data. It looks for patterns and correlations in the data, and normally the patterns and relationships are too complex for just regular data analysis, or the data sets are just way too big. So this is a good way to get information from big sets of data. And it's important because it has a lot of different uses and a lot of different applications. People use it all the time, but some of the most important features of data mining is that it can be used for forecasting, for cutting costs, or maximizing revenue. So here me and Danica defined what we feel like are some of the 5 most used data mining paradigms. In our research, these are just the 5 things that kept coming up. There are a lot of different things, but we just felt like these are the most important. So we start off with Kmeans clustering. This is something we've talked about a lot in class. It's a method of classifying data into K clusters. So the user defines the number of clusters ahead of time, so like 2 clusters or 3 or 4, it doesn't really matter. And then the algorithm runs and assigns each data point to a cluster made of similar characteristics. And this method is usually used to solve optimization problems. Then we have unsupervised machine learning. This is a type of machine learning where the data has no specified or labeled output. So you don't really tell the computer anything ahead of time about the data. You just put in the raw data, the algorithm runs and attempts to find patterns or groups in the data without any guidance or interference from the user. There are a lot of examples of unsupervised learning, but one of the most common is a self-organizing map. We have a picture of that here. This particular map has classified data into poverty regions. So in the upper left corner are the least poverty-stricken countries, and the bottom right are the most poverty-stricken. And this type of machine learning is used to organize and understand data sets. So decision trees test data attributes such as outlook here. It moves through the tree based on the value of the attribute. So outlook has 3 possible values: sunny, overcast, and rain. And depending on the value of the attribute, it moves down through the tree. So if you start out with outlook and the value is sunny, then it moves to the next attribute, which is humidity. This is a pretty cool algorithm. It has been used to diagnose medical conditions and in evaluating credit risk of loan applicants. And then we have the nearest neighbor algorithm. This is commonly used to solve a traveling salesman problem. This is a problem that we've done a lot of work with in our classes. So you create a starting point, then you move to the nearest data point or the nearest neighbor. That's where the name comes from. And then it sets that new location as the new starting point. So then it moves to the next nearest point and just repeats until all the points are visited. And this is used to solve optimization, like minimization and maximization problems. And then finally, we have the a priori algorithm. This algorithm checks the frequency of certain data in the data set, such as how many times A occurs, or B occurs, or C occurs. Then it checks to see the occurrence of 2 types of data together, such as both A and B, so where A and B both occur together. Then it moves even further and checks 3 types together, such as A, B, and C together. This is often used in retail stores in order to see what items are bought together so they can be placed near each other on the shelves. Amazon also uses this algorithm to recommend items to you based on what you're purchasing. So that was just an overview of the different types of data mining methods, and then Danica is going to demonstrate for you some of those methods in MATLAB.
Now that Ashley has described some of those data mining paradigms to you, I'm going to show you how 3 of them can be executed with the program MATLAB. The first paradigm I'm going to show you is decision tree regression. The code above is in MATLAB and is originally from mathworks.com. In this situation, we are using the dataset car small to predict MPG from horsepower and weight. When the MATLAB code is executed, these decision tree steps are printed for the user. They explain how to make decisions given certain circumstances in the data. To show you an example of how this works, we will walk through the first 3 steps of the diagram. We read the first step starting at the top of the decision tree. It says if x2 is less than 3085.5, then we should go to node 2 on the left side. If x2 is greater than or equal to 3085.5, then we should go to node 3 on the right-hand side. If neither of those things are true, then the MPG is 23.7. In the next step, if x1 is less than 89, then we go to node 4. If x1 is greater than 89, we go to node 5. As you can see, this is happening after node 2. So step 2 correlates to node 2. The next step, step 3, correlates with node 3. If x1 is less than 115, then go to node 6. If it's greater than or equal to 115, go to node 7. And so on and so forth until the decision tree is finished. The next MATLAB code is for K-means clustering. Here, we use the dataset Fisher's iris. When we plot the data, it looks something like this. Now let's get into the K-means portion of the MATLAB code. The K-means x, 3 means that the K-means ++ algorithm is used to divide the data into 3 clusters. In this part of the code, the IDX region returns the cluster indices. Finally, in this last part, the code tells MATLAB to plot the different cluster regions. We can see them here. When we defined the 5 most important or most used data mining paradigms, we mentioned unsupervised machine learning. There are specific algorithms that fall under this category, such as those listed below. We will be looking at self-organizing maps in MATLAB. Self-organizing maps are a way for our computers to organize information based on characteristics of the data. In MATLAB, a neural network is used. When data is put into the neural network, it outputs this diagram. In addition, the user can see maps such as hits, neighbor connections, and neighbor weight distances.